Welcome to the latest edition of Reimagine Mobility podcast series. I'm here with Daniel Schwarz.
Good to see you all.
Daniel, thanks for joining me. You've been in engineering 10 plus 15 years, 20 years, I think.
20 plus. It's
20
been
plus
a while.
years,
Yeah.
a long time.
Yeah,
You have moved now more onto the customer-facing business development side.
that's right. Yeah.
So tell me a little bit about your customers and what's the most interesting thing that you've learned already now in the short period of time from your customers or about your customers that maybe before, when you were on the engineering side, you never really realized?
Well, I've been with AVL for a long time, 20 plus years. Started out as a mechanical engineer by trade. And you're right, a few years ago, I transitioned more into this business development role, which I tremendously enjoy because it's a very dynamic time that we live in, especially when it comes to our industry, right? And the topics that are being discussed in the industry, the transition from fossil fuels into new emerging technologies, is something that's tremendously exciting and makes for interesting conversations and working days, I have to say. Yeah.
And what are some of the things that you now learned about your customers, maybe how they behave, how they interact with companies, internally, externally, that maybe before you never really recognized when you were more on the hidden from the customer, let's say on the development side? Is there anything that sticks out to you?
Well, here's the thing though, because I was never really hidden from the customer, because at the position I held within engineering, you're still at the forefront, and engaged with customers on a daily basis. So I developed business for a long time, not just for a couple of years. But I think it's fair to say that the customers themselves sometimes try to make sense of all the options that we have nowadays. Because I think the one thing that we can agree on is that we need to decarbonize, right? But how to get there, right? What is the right solution? What is the right energy carrier, right? Is up for discussion, I guess. And depending on the application, it's a different answer. And some of our customers, are in the midst of trying to figure that out for themselves. And I think this is where we could come in, right? And if you look at it, I mean, the sheer bandwidth of different applications, and we're talking just wheeled mobility here, for instance, right? So everything from a motorcycle or a passenger car, over pickup trucks to commercial vehicles. Then you have the construction equipment, you have agricultural machines. It's a huge bandwidth, right? That needs to be addressed going forward, because the one thing, again, we agree on, we need to decarbonize. But how to get there is many different ways. And it's an exciting time to be in that industry.
Do you have some customers that are, let's say, 90+% there and know where they want to go, and you have customers that are maybe only like 10% there, or is it really most of them are easily on their way, they know what they want to do, they just need to kind of come to us or go to other people for slight course adjustments, or is it really all over the place? Some are almost there, some have just kind of started the journey. What do you see?
Well, it's difficult to put it in metrics, I think, but I guess it's fair to say that certain use cases, and if you look at passenger cars, for instance, so if you look at a General Motors or a Ford or a Toyota, right, passenger car established large OEMs, I think it's fair to say that besides, pushing the so-called legacy technologies like internal combustion engines, the primary course of action is certainly going to be EVs, right? We see it everywhere in the industry. Battery electric vehicles will play a very significant role in that particular area, in that niche. If you expand the envelope a little bit and look into customers who deal with on and off highway, or maybe construction or agricultural machines, it becomes a completely different equation, right? One of my customers is one of the leading global agricultural machine OEMs, right? And construction equipment. And they sit at the source of renewable liquid fuels like ethanol, for instance, which makes a lot of sense for them because they can have a sustainability cycle, within their customers where corn is being planted, harvested, you can turn it into ethanol and fuel large machines with that fuel. And it's a very appealing a carbon reduction with it, right?
Yeah.
On the other hand, as the machines get bigger, you cannot switch to electrification. So you need to stay on that liquid fuel. The smaller ones, of course, can be electrified. So they are facing a situation where they have a bandwidth of energy sources, and they are in the midst of trying to figure out what is the best for their application.
Sure.
And we got to be careful here, because everybody talks about electrification, and electrification certainly has its right applications, right? No doubt about it. But going ahead and electrifying everything without taking the other options into account, first of all, is not practical, and would be short-sighted, right? And again, that brings me back to my point, that what makes my life in business development so interesting. And some, as I said, are closer to the answer and already deployed their development processes and are well on the way with their product development initiatives. Others ask a lot of questions and try to figure out where's the future taking them.
When we talk about figuring out where somebody may or may not should go or could go, right? We do quite a bit of simulation work at AVL. We pride ourselves with our own simulation tools that we develop in conjunction with engineering for close correlation between simulated and real world, all that good stuff. And we also use what we call front loading. How much of front loading are people doing, your customers doing today to develop their product, or maybe just to get a glimpse of what would it be if I were to go with ethanol, if I were to go with hydrogen, if I were to go with, are they only using front loading or simulation to really start their development process and take it all the way through, or they do also use it for kind of feasibility studies, but do those feasibility studies that we used to do physical, now they do it in simulation? Share a little bit about that.
Yeah, that's a great question. And you asked me how much of my customers are using that. I'm saying, yes, they are using it, but not enough, because it's a fantastic tool to really help filter down technology options and also reduce overall development time and development cost, right? When you look into the power and the maturity level of those simulation tools, they are really, really impressive. I mean, AVL have been doing simulation tools for a long time, right? I mean, over 2 decades ago, we created a department, trying to tailor specific solutions for what we do, because we felt the commercial available off-the-shelf software package were not cutting it. Now, what you do with it can go in many different directions. You can use it as a concept study to filter down on a very high level, right? But you can also use it in context of very real engineering challenges that you face today. And what I mean with that, and I'll give you an example, right? Large engine OEMs, OEMs that build large engine for power generation or marine applications. So we're talking engines that cost as much as my house, maybe not yours, but certainly my house, that are as big as this room, generating thousands of kilowatts of power. Those engines need to be developed, and at some point they end up in a test cell and run in a test cell and burn astronomical amounts of fuel. So we're talking about 3/4 of a ton, a metric ton an hour that is just being converted, right, into torque and power. Now, a lot of those engines have design similarities because of the cost of the unit. Talking about the engines, you typically don't do one specifically for one application, do a completely one for different application. So there's some commonality on those engines, and they need to work in different use cases. And let's say you have one for generating power, the other one is in a marine vessel, right? If you would fully develop that one engine application, meaning calibrating it on a test cell, talking several months of calibration work, I just told you they consume up to a metric ton, some more, of fuel an hour. So you're looking at $20,000 during an 8-hour working day just in fuel. You multiply that with several days, weeks, months, talking a ginormous amount of money. Now, what one of my customers started doing recently, and we were part of that, we try to explain, look, if you use it, or if you approach it differently, right, and you calibrate smarter rather than being in a test cell, we can model your engine, the thermodynamic behavior, the transient behavior from the turbo machinery. We model your engine. We have all the actuators from that engine. We put it what we call into a virtual test bed. And then you're able to operate that engine on that virtual test bed. To the engineer, it looks like the real interface. There's no difference between the physical engine running
in a test cell,
or on the virtual machine. You have your same measurement channels, the screen looks the same, and you can do a lot of work virtually without burning a single gallon of fuel, right? And you can do that at such an accuracy level, such a maturity level, that, to put it in context, an 80% mature calibration can be easily developed on that VTB. So by the time you move into the real test cell, you are already 80% there, right? So you save a lot of time, you save a lot of money, and equally as important, these engines are very expensive. I mentioned that, right? You're talking $500,000 just in the engine cost itself. If you end up with something that's a prototype that hasn't run before, and you make a mistake as the calibration engineer, you can cause serious damage to the engine, and that needs to be repaired. So you get downtime, you get replacement costs. If you do all of that ahead of time on the VTB, you create something that is ready to run, it's safe, it's proven, and it's already 80% there. So that, for instance, is a great example on why it makes so much sense to front load in order to save money and save time to market.
Let's go to hydrogen, right? Hydrogen has really come up, obviously, over the last 3 to 5 years, maybe out globally. In the US, I would say over the last 2 years, we've seen an uptick in hydrogen and fuel cell. But now with the IRA, the Inflation Reduction Act, it seems like we've taken another step, or we shifted another gear, if you want to say so, or speed up even more. We see some of your customers making major investments. The heavy-duty truck OEMs suddenly are looking at it again for some applications. We're seeing stationary power systems starting to use that versus diesel. What do you see from your customers? What are they looking at when it comes to hydrogen? Is it really driven purely by the IRA, or is kind of the IRA pushing it over the edge to say, okay, now we're going to do it. Now this is kind of the last thing we were waiting for. We were sort of, again, for particular applications, convinced before. But share a little bit what you see there.
Well, personally, I think hydrogen is a fantastic energy carrier, right? It's abundantly available in the universe, first of all, and it has fairly high energy density. So I think hydrogen is a great energy carrier. We're still very early in that journey because you can use hydrogen on a wide range of propulsion systems. And you mentioned fuel cells, which I'm a big fan of. I said 15 years ago, I think ultimately the journey will carry us towards the fuel cell, which is great, by the way, because all those electrification know-how that we're gathering right now on battery electric vehicles is going to be directly applicable, right? Because we're still talking about an electric vehicle at the end of the day. Even if it's fuel cell powered, right? So all the e-axles, the e-motors, the inverters, the control strategy, functional safety to a degree, the battery itself, all of that will be carry over. But the battery...
We sort of go back to a hybrid approach almost.
Almost. Battery will decrease in size, which is also great because that has a lot of sustainability concerns and recycle concerns in itself. So that's all great. Hydrogen as an energy source obviously can also bridge the current technology that we have, meaning transitioning established internal combustion engines burning fossil fuels, right, into something that operates carbon neutral, because hydrogen could also be used in internal combustion engine architectures as we pretty much know it today. Of course, the big challenge on hydrogen is to get it cost effective, right? And that's the nuts that we as mankind will have to crack. But I'm pretty confident, if you look back in history, we have come across many, many different challenges before.
If not, you go back into engineering.
That's what we are here for ultimately, right? Exactly. But no, I think hydrogen is a fantastic fuel, whether it's as long as it can be generated green and sustainable, right? And there are some interesting models, for instance, at the coast of Chile, right, where you have an abundance of of wind coming in from the Pacific coast, electricity could be very, very cheap there, right? Yeah. And if you use the Pacific nearby to desalinate water, and you have cheap electricity, there is a case where you should be able to produce hydrogen at a much more cost-effective rate than today. Right. When it's ultimately super cost-effective, we'll see, but it's a great energy carrier, and ultimately I think fuel cells will become a major source of energy generation. On board in vehicles, right? Could be generated, stationary power can be generated with it. Marine is a fantastic application. Not so sure about aeronautical world yet, but we'll see. But the fuel cell is great, and the fuel cell in context with hydrogen is a very viable solution for the future. And I'm very excited, and customers already notice that. We're getting a ton of inquiries on fuel cell projects for stationary power generation, but also for mobility. We have a very interesting fuel cell integration project coming up where we integrate the fuel cell into a Class 8 truck, which brings me back to the right fuel for the right application. Because at the end of the day, some of those vehicles are just not battery electric compatible, right? Every vehicle that needs to work hard and runs at a high load factor for a long time during the day can't be battery electric, because you would end up with so much battery that the cost and the weight is just not economical, right? And that's why I think for long haul applications, meaning tractor trailers moving load from one side of the coast to the other one, hydrogen and fuel cells would be a fantastic propulsion concept. Of course, you have the infrastructure and all of that, but hey,
chicken and the egg to some degree,
but we are at the beginning of a journey.
Yeah.
Again, what we can agree on, we need to decarbonize. What is the right strategy depends on what you need to do.
Sure.
Yeah.
Okay. Very good. Thank you, Daniel, for your time.
Anytime. Thanks for having me. Thank you so much.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.